All right, here's a good question. It says recent trip, Sarah's car traveled 20 miles an hour faster on the first 130 that it did on the remaining 80. So distance, this is the first part of the trip. Uh, First part of the trip, second part of the trip, and total. Not sure if we need the total. Although that's an interesting idea. Because if you take the total and divide it by the time that it took, then you get an average time. But I'm not sure how that helps you with this. Just because the distances are different. I like that. Anyway, the total trip of the time was 4 hours. So let's call this one time for the first, and we'll call this time for the second part of the trip. So if I start there and say the time for the first plus the time for the second gives me 4 hours. Now I have this formula, distance is equal to rate over time. No, rate times time. Yeah. Distance equals rate times time. Is that right? Yeah. Distance equals rate times time. That's my formula. If I manipulate that formula, divide both sides by r, I'm solving for t. I have d over r. So, here's a t, there's a t. So what I can do is I can say, well, the distance that you went for the first part divided by the rate, the speed that you went for that first part, that'll give me the time that I went for the first. Same thing with the next one. That should have been a time. The time for the second, so it would be the distance for the second divided by the rate for the second is equal to 4. Okay, good. So now the distance for the first part was 130. Rate for the first part, x plus 20, plus distance for the second was 80, over rate for the second was just x. So this has to equal to 4. So there I've got a nice rational equation that I can solve for x. I just have one variable. So let's try and solve it. Common denominator is going to be x plus 20 times x. So I'll take it and I'll multiply this by x and x plus 20. Multiply this one by x and x plus 20. And multiply this one by x and x plus 20. So these cancel. So this first one will just be 130x plus. The x's go. So this will be 80 times x plus 20 is equal to 4x times x plus 20. Oh, looks like I'm going to get a quadratic here right on. 130x plus 80x. Also, feel free to stop at any point along here if you sort of say, oh, I got it from here, Jeff. And then you can finish off and see if I get it right. 4x squared plus 80x. Okay. So there's an x squared on the right. Let's move everything over to the right, and we'll get the left to be 0. So I have a 4x squared plus 80x, and then minus 130x. So that's gone. Minus another 80x, gone. And then minus 1600. Is that right? I think that's right. Okay. Keep going here. So I have 4x squared. The 80s go, so this would be minus 130x minus 1600. Okay. 2 will divide into everything. So 2x squared minus 65x minus 800. Okay, and now factor. Great. I'm a guess and check guy. 2x and x. 80 and 10. Would that be too easy? Say I put 10 here and 80 there. 2x squared plus 20 minus 80. Oh, that gives me 60. Right, 20 and 80 would be 60. That's close. So instead of 80-10, I wonder if there's some other numbers that might be close to that. 16 and 5. No. 40 and 20. If I put 40 here and 20 there, so that'd be 80 minus 20. No. Okay, so here's where this gets a little bit, so what I'd like to do, and I could keep fighting with it and see, or you can always fire up your decimals or your graphing calculator, because it's a quadratic, and I know the answer to that will be an x-intercept. So I can just plug it in here. So I guess I got to remember what the thing is. 2x squared minus 65. So 2x squared, go over, minus 65x minus 800. Okay, good. That's crossing at 10. Maybe I was right at 10. Let me shrink this a bit. Oh, it's not at 10. What's that point? 42 and a little bit. 9 and a little bit. Okay, so at this point, I'm thinking, did I do something wrong? Or maybe it's not factorable. I did pause the video and go back to see if I did anything wrong, but I hadn't. Anyway, because these points aren't bang on, it tells me that I can't factor that. And so, let me just get out of this decimals thing. So since I can't factor it, then what I can do is just use the quadratic formula with it. So let's do that. Get rid of this stuff. Now let's use our quadratic formula. It's always, I guess it's not a bad idea to try and factor something, but sometimes when the number's a little big like that, hard to factor, maybe just throw it right at the quadratic formula. So minus b plus or minus square root b squared minus 4ac all over a couple of a's. So minus b is a negative 65 plus or minus negative 65 squared minus 4 times a is 2 times 800. Gee, hopefully that'll come out positive. All over 2 times a is a 2. Okay, let me see if I can plug that into decimals. You can tell I'm sort of addicted to decimals a little bit. Whoops. Okay, so right up here, I'm going to type in a bracket first. Okay, so negative bracket, negative 65. I'll put a bracket right at the start there for the fraction so I can make it divide later. Okay, plus or minus, let's just go plus. I can't do a plus or minus on this, I don't think. Square root of bracket negative 65 bracket squared, go over, minus, I want to be right there. Keep it under the square root sign. Minus 4 bracket 2 bracket, open up another bracket, 800. Okay, close that bracket. And that's it for the top. So I can go over, whoops, finish that bracket, divided by 2 times 2. 2 times 2. There we go, undefined. Why is that undefined? Oh, It's a negative 800. That's why. There we go. 42. So x is equal to 42.019. Okay, so, and you could do the negative one, but it'll be smaller than this one, and it might even be a negative number. So I don't know if you can do, I guess I can do it right here. It's pretty easy. Just go up and tap, oops, tap, tap. You can get rid of that and put a minus in. Yeah, it gives you a negative number. I don't want the negative version. I want the positive version. Okay, so 42. So x is 42. Okay, get rid of decimals here. So x is 42. So now if I go back to look at what we have, x is a 42. So this is 42. And the question says, how fast was she going on the first part of the trip? Well, she was going 20 miles an hour faster, so she must be going 62. Okay, hopefully that helps you with that. That's a nasty question, eh? Like, you do all this hard work, and you'd think at this point they'd give you something nice, easy, factorable one. No. Quadratic formula. All right, hopefully that helps.